Jeez.
Because no, watch. You see that?
Still gonna die in like 5 minutes.
No, because I got it.
Yeah, but it's
Yeah, and that didn't work last time.
It's the honor.
Hey, sure.
Hello? Hello?
Because Addison was trying to draw him.
Hello.
It didn't work.
Better move the dog.
That's fine.
Or use a bear the dog.
All of them.
You already went? Okay, thank you. Good morning, ladies and gentlemen. How are we doing today? Good, wonderful, excellent. Glad to hear. Wonderful, ladies and gentlemen. Wonderful. All righty. Take out your periodic tables. Take out your computers and get logged in, ladies and gentlemen, and start thinking about the question of the day, which is name a metal or a non-metal on the periodic table and tell me its charge. So we'll get to you in a second, ladies and gentlemen. Let me get attendance, and then we will go from there.
Wait, no, it's also supposed to be.
I think it's just like a really good drawing in the middle.
All right. You're supposed to help the person. I just wanted to take care of that. All right. Morning, Aiden. All right, ladies and gentlemen, welcome to Monday morning, the last of our month of January this week, ladies and gentlemen, which is good because that means we're 1 month closer to warmer weather. So, today, ladies and gentlemen, we are going to start writing and naming binary ionic compounds. That is what we are going to do. There is a worksheet that is online for you to get some practice with it. There is also the keys online so that when you are practicing, you can see if you're doing it correctly. So that if you're not, you don't do a whole bunch of worksheet and find out you're doing it all wrong. And just remember, ladies and gentlemen, if you are missing things, you need to get caught up. If you want to redo a test, you need to bring me the test with corrections made to it, and then you can retake the test for Unit 2. Unit 1 retakes are over, ladies and gentlemen. They are done. So this is now about Unit 2 stuff. Okay? So you should have gotten your test back last week, ladies and gentlemen. You should have, we went over them with you so that if there were any questions, you should have been able to get those answered. But if you need to see me about something, you are welcome to. I am here most days after school. And I am here every morning before school except for the last day of the week. So, questions? All right. I will tell you this. If you need to do a retake on the unit test, better get at it and better get it done soon because the longer you wait, the harder it's going to be. Okay? People ask me, are the retakes the same as the original test? No, they are not the same, but it is the same material that you are going to be being quizzed on or being tested on. So while I may not ask you the exact same questions, the topics will be the same on the retake as they were on the first test, just so you know. And if you had a score of less than a 70% on the original test, you can do a retake and get up to a 75% on the retake, which will improve your score if you do that, ladies and gentlemen. Okay? On Friday, ladies and gentlemen, we left off with talking about the periodic table and about the charges of different elements on the periodic table. Okay? So let's begin with this. Name me either a metal or a nonmetal and tell me what its charge would be. Now, before we do that, though, ladies and gentlemen, before we do that, this is where we left off on Friday. Okay? We had just finished going through this. These are the different families of the periodic table, or groups from group 1 to 18. Now, we did ignore groups 3 through 12. Why? They don't fit the pattern that we are trying to establish. We will talk about how we handle those a little bit later. But everything else on the periodic table, you can find its charge based on what family it's in. Okay? So everything that is in group 1, ladies and gentlemen, all of the alkali metals are a +1 charge. All of the alkaline earth metals are a +2. All of the boron family is a +3. In the carbon family, it is a +4 and a -4. Now, a couple of you asked last week. Well, I said, Mr. Rand, you said that metals always do what with the electrons? They lose them. So they always have what kind of charge? Positive charge. So that means when we get into group 14, and we have 2 nonmetals at the top, and we have 4 metals at the bottom. And by the way, the last few elements here, these down at the bottom, these are man-made elements that we know very little about still. We've created them in the laboratory somewhere. Now, the one thing we can say is based on where they are at, they should behave the way the rest of the family does. In other words, nihilium should behave like a metal does. But it's a man-made element. We've only created a few atoms of it ever. there is no practical use for it. Okay? So to call it a metal, yes, we can. To say that its charge would be a +3, we could. To say that it is found in any common compounds, no. Doesn't happen. Okay? Doesn't happen. All right? So the same way here. There are technically 4 metals at the bottom of this family. Flovium is one that is a man-made one as well. Not going to find it in any compounds. We're not going to give you a compound with it and chlorine put together. Okay? So just keep that in mind, ladies and gentlemen. Okay? But because these are metals, they obviously will have a +4 charge. Because the ones at the top are non-metals, they are going to have a -4 charge. And why is that? Because they have 4 valence electrons. And it is just as easy to gain 4 electrons as it is to lose 4. You're halfway filled. Okay? Then we go on to group 15. They have 5 valence electrons. Most of those would be a -3. Group 16, the oxygen family, would be a -2. Group 17, the halogens, would be a -1. And then finally, ladies and gentlemen, so when you get to group 18, now those elements have no charge, 0. They don't gain, they don't lose electrons, they don't do anything. Why? They are already stable. And that's why atoms gain or lose electrons to become stable. So why would you gain or lose electrons if you are already that way? Okay? So simple question for you. Name me either a metal or a non-metal and tell me what its charge is. Go. Lithium, what's its charge?
+1.
Good, +1. Go.
Fluorine.
Fluorine, what's its charge?
Negative.
Negative what?
-1.
Thank you. And again, we do need to be specific. Okay? So if you say 1 as the charge, I'm going to say what kind of 1? Positive or negative? If you say negative, I'm going to ask how much negative. Okay? Go. Pick one. Argon, 0. Pick one. Magnesium, +2. Get in early before all the good ones are gone.
Sodium
Sodium,
+1.
+1.
Wait, lead is positive, right?
What?
Lead,
Lead is positive. So what would it be?
+4.
+4. Good. Hydrogen, charge. And actually, hydrogen is unique. I'm not going to argue with you. Hydrogen can be a +1. What else could hydrogen be, though? It could also be a -1. Technically, it is a non-metal. It would be a -1, but it can also be a +1 because it can lose 1 electron as well as gain 1. Okay? So it is one that's kind of a little bit special. Good. Give me another one. Come on, our quiet side of the room over here. Nitrogen, what's its charge? Nitrogen? You sure? What group is nitrogen in? 15. So what's the charge of the nitrogen family? -3. Okay, -3. Haley. Potassium, what's its charge? +1. Good. Jasmine. Pick any metal, any non-metal you want. Okay, what would iodine's charge be? Go up to the top of iodine, and what group is it in, Jasmine? So what is group 17 always here? -1. Nadia?
Neon 0.
Neon, 0. Daniela? Oxygen, -2. Leave. Xenon, 0. I think I had called on you before. You volunteered before. Brindley?
How do you say that?
There's 118 elements. Pick one you can pronounce.
What does that say?
Which one?
Is that that calcium?
Yeah. It's the stuff that goes into bones.
Yeah.
What's the charge?
+2.
+2. Good. All right, ladies and gentlemen. So here's what I want you to do on your periodic table. Wait. I'm waiting. Go ahead. What? We're going to talk about those in a minute. Okay? But before we talk about those in a minute, yes, Shara. You're what? You got to start bringing it, Jara. Yes, you can. I know, but okay. Go get it, please, because we're using it every day now. Every single day. All right? All right. So here we go, ladies and gentlemen. So on your periodic table, down at the bottom, ladies and gentlemen, right under francium, element number 87, please put +1. Underneath radium, element number 88, please put a +2. That is going to tell you what the charges of those families are. So I don't care if it's lithium, sodium, potassium, rubidium, cesium, or francium. In a compound, it will always have a +1 charge. The reason it has a +1 charge is they all have one valence electron. They all lose that one valence electron. They all become stable as a +1 ion. Beryllium, magnesium, calcium, strontium, barium, and radium all have two valence electrons. They lose those two valence electrons to become stable. And when they become stable, they always have a +2 charge. Now, Cynthia asked about 3 through 12. We're going to talk about those in a couple of minutes. But for right now, we're ignoring them so that we can establish or set this pattern. So now we go to group 13. We go down to the bottom of 13. Under nihilium, we are going to put a +3. Now, here's what I will tell you, ladies and gentlemen. Very rarely will I even give you a compound with thallium in it. Thallium would be a +3. By the way, please be careful. This is a capital T, and that is a lowercase l. Okay? Be careful because titanium is a capital T and a lowercase I. Sometimes people get the I and the L here confused as to if that's an I or an L. Well, it's got to be lowercase, the second letter. Okay? Under fluvium, we are going to put a +4. Okay? We are going to put a +4. Now, on top of carbon, we are going to put a -4. Now, why do I put the -4 up there? Why do I put the +4 down here?
That's where charges, like when separated by.
Different groups.
Yeah.
Well, technically, this is the same group.
The top ones would
Non-metals
be
versus
gases.
metals.
No, not gases.
Not metals. And so they'd be negative charge.
Okay. At the top of the periodic table in these groups are the nonmetals. Nonmetals always have a negative charge, so I'm putting the negative charge up here. So that if you go to group 14 and you see this bold line, are you above the bold line and go up? Or are you below the bold line and go down? If you're below, you're going to go down, you're going to be a +4. If you're above, you're going to go up, you're going to be a -4. Questions? Okay. So then what do we write above nitrogen, ladies and gentlemen? -3.
What happens if you're below the bold line?
We'll talk about that in just a second. Let's finish this out, and then we'll talk about that. What would be oxygen's charge? -2. The halogens and the noble gases? 0. Now, the question that Levi just asked is a good one. What is technically the charge on boron, ladies and gentlemen? It can't be +3. Why? Because it's a nonmetal. So if you had to predict its charge, you would say -5. Now, here's the fact. I never give you a single compound where boron acts as a -5. I don't. Okay? I don't. It's more of an exception than a rule. We'll avoid those. The same way, though, come down here. What would bismuth's charge be? Bismuth would be a +5. Based on our pattern, it would have to be a +5 because the group next to it is a +4. It is a metal, so it's going to be positive. What would be polonium? +6. Okay? Now, those are rare, and I will avoid those for you. Okay? But that can happen. Okay? So now Cynthia wants to talk about groups 3 through 12. First of all, that took care of these, right? These ones that are in these mixed groups that maybe are at the bottom or at the top, but like here, boron. Okay? Any questions on those? Okay. So let's talk about these in groups 3 through 12. The reason that we cannot tell you what charge they are is because many of them have multiple charges. In other words, the electrons do some funky things. And how they become stable varies depending on the element that it is. So for example, iron, which is common in a lot of compounds, can sometimes act like a +2, can sometimes act like a +3. Now, we didn't want it to be this way, but this is what we found by looking at iron in compounds, is that sometimes it's acting like a +2 with what it's with, sometimes it's acting like a +3. So therefore, we can't tell you what the charge is. We have to actually find it, and we will show you how to do that. The same thing with copper. Copper can be a +1 or a +2. Cobalt could be a +1 or a +2. Chromium could be a +3, a +5, or a +7. So sometimes there's very little rhyme or reason to it, but this is what actually happens. Okay? And it's not that we wanted these things to be like this, but this is how they react with other compounds, and this is the only way we can explain them, is that they are giving this apparent charge of a +7. Okay? That is what we know from studying compounds. So we are going to, for the most part right now, ignore these because we can't find their charge the way we can the other ones. Now, we will show you how we can handle those. And there is a way that we can do it. And as a matter of fact, we're going to put a couple down right now that are very common that we use that we need to know their charges. So the first one that we are going to do, ladies and gentlemen, is zinc, number 30. Zinc is always a +2. So I'm going to put a +2 by zinc. Right there in the box with it, only zinc. Zinc is the one that when it is in a compound, it always acts as a +2. Element number 47, silver, is a +1, always, always. And those are metals that we are going to use commonly in compounds. So if we're using zinc or we're using silver, I do not have to tell you the charge because I've just given it to you and you can find it on your periodic table. Okay? Questions? Okay. Now, for every rule, there is always an exception. And the exception that we're going to talk about right now is tin and lead. Tin and lead should be what charge according to the periodic table? +4. They are metals, so they are below the line. They are in the family that will lose or gain 4 electrons. However, what we know is this, ladies and gentlemen. Tin and lead could both be a +2 or a +4. Those two elements are the only ones that are in what we call these main groups. That even though they should be a +4, they can actually be something else. Okay? They can actually be something else. So they could be a +2 or a +4. And you won't get to understand why exactly until Unit 8. The end of the year. Then we can kind of explain it to you better. Okay? So, what my expectation is that if I give you an element like strontium, you can tell me what its charge is. What's the charge on strontium, element number 38? +2. If I were to ask you about iodine, what charge does iodine have? -1. If I were to ask you about phosphorus, what charge does phosphorus have? -3. Do we have any questions on this right now? Okay. And again, you're going to be using your periodic table every day in this unit because we are going to write compounds, we are going to name compounds, and this is going to be what you're going to need for that. Questions? All right. So again, keep your periodic table handy because we are going to be using it quite often. All right, so here we go. By the way, again, the noble gases, group 18, they are called inert gases because they are unreactive. And they are the reason that we say all of the other atoms are trying to become stable, to fill their valence shell, to fill their outermost shell. The reason being, they have a full shell, and they do not react with other elements. They do not combine with other elements. Okay? They stay pretty much off on their own. Questions? All right. So today we're going to start writing compounds, and we're going to begin with the most simple compounds we can, binary ionic compounds. What does binary mean? 2. So these are compounds that contain 2 different elements. One of them has to be a metal. The other one has to be a non-metal. Okay? One has to be a metal, one has to be a non-metal. And they are created by atoms gaining and losing electrons. So a metal will lose electrons to a non-metal. The non-metal will gain electrons. When the metal loses electrons, it becomes positively charged. When the non-metal gains electrons, it becomes negatively charged. And then what do you know about 2 oppositely charged objects? They attract and they are stuck with each other. They attract and they are stuck with each other. Okay? Now, the reason that they are attracted and stuck with each other is because they both wanted to become stable. They both wanted to fill their outer energy level. But by doing so, they end up being attracted to each other and stuck with each other. Okay? So, we have 2 things that we are going to do. We are going to write formulas and we are going to name compounds. Okay? To write a formula, ladies and gentlemen, we write the symbol of the metal with its charge first. Metals always go first. The reason for that is we don't want Levi writing a compound metal, non-metal, and Brindley writing the compound non-metal, metal. So for the sake of being consistent, metals always go first. Okay? And we need to know their charge. So we write down the symbol with the charge, magnesium plus 2. We then write the symbol of the non-metal with its charge, fluorine minus 1. Now, for everything to be stable, ladies and gentlemen, magnesium has to give away its 2 electrons. Fluorine, though, only wants to gain 1 to become stable, because when it gains 1, it becomes stable. So there may be a compound where you have multiple of one kind of atom compared to another. The reason for that is you want all of the atoms in your compound to be stable. So magnesium wants to lose 2 electrons, fluorine will only gain 1. The only way magnesium can lose 2 electrons is if there is a second fluorine around. Okay? If there is a second fluorine around, then they will combine. So we are going to do something called the crisscross method. The crisscross method is a method where when you write a compound, you are guaranteed to get a compound with a total charge of 0. And that is when everything in the compound becomes stable. When the total overall charge on a compound is 0, the compound becomes stable. All of the elements in the compound become stable. The one thing that will never fail you is the crisscross method. It will always get you to a compound that has a total charge of 0. Always. Okay? And what we are going to do is we are going to crisscross superscripts into subscripts. That is what we do. Superscripts are these numbers that are written up above. Subscripts are the numbers that are written down below, like H2O, the 2 in H2O, that is a subscript. So we are going to take superscripts and we are going to crisscross them into subscripts that will guarantee us a total charge of 0. However, when we do this, subscripts are only positive numbers. Subscripts say how many of that atom are in the compound. Well, can you have -1 of an atom in a compound? No. So subscripts have to be positive numbers. We don't write any negative numbers. Since they have to be positive, we don't even need to put a sign by them. We also don't write any unnecessary things. By writing the symbol, you're saying there is one of these things there. So by writing the symbol, since there's one of them there, we never write the number 1 in a formula. You will never see a formula H2O1. It does not happen. Okay? Does not happen. Now, the one place the crisscross method can let us down is we have to reduce your compound into lowest terms. We have to reduce a compound into lowest terms. And the reason being, there are an infinite number of ways that you could combine two elements and get a charge of 0. An infinite number. So we don't want 4,000 different ways of writing the same compound, because Eli needs to write Na2Cl2. I'm sorry, Levi. Sorry, my bad. I don't know where I got Eli from. Because Levi needs to write Na2Cl2 and Leaf needs to write Na3Cl3, even though Cynthia wrote NaCl. They would all be the same compound. So we always reduce into lowest terms. Okay? We always reduce into lowest terms. All right. So, with that in mind, ladies and gentlemen, the example that we had was magnesium, which is a +2. Now, we just went over how to find out that magnesium is a +2. And that is because on your periodic table, magnesium is in column 2 or in group 2 of the periodic table. And everything, group 2 is a +2. We're going to put it with fluorine, which is a -1. Now what I'm going to do is take these charges from up above, and I'm going to crisscross them, and I'm going to bring them down and turn them into subscripts. So with that, our formula looks like this. Mg -1, F +2. Now, a couple of things. Number one, we never write minus or plus signs. So I'm going to get rid of that. I got rid of that, which I'll put the G back. Now I'll put the Mg back. Okay? We also never write the number 1, so I can get rid of that. So this, ladies and gentlemen, is our formula. MgF2. That is the formula for this compound. Now why? Magnesium has 3 levels of electrons. 2 that go in the first. 8 that go in the second. And 2 that go in the third. Fluorine has 9 electrons around it. Fluorine has 2 in the first and 7 in the second. What that means, ladies and gentlemen, is magnesium will gladly give away one of its electrons to fluorine. Why? It's closer to being stable. This fluorine is now stable, but it has a -1 charge. This magnesium is not stable. It still has 1 electron in its outer shell. So it needs a second fluorine atom that had the same situation as the first. which is it had 9 electrons. Why? All fluorine atoms start out with 9 electrons. So magnesium says, all right, fine. The other fluorine can have this one. That makes both of these fluorines -1. Because magnesium lost 2 electrons, it becomes a +2. The total charge, +2 minus 1 equals 0. That is what all ionic compounds do. They combine in a way so that everything becomes stable and that all of the charges on the compound when added together equals 0. And this crisscross method will never fail you to get you a charge of 0. Questions? Okay, if you are going to name these compounds, we are going to write the name of the metal. That's it, just the name of the metal. Magnesium, you don't have to put any charge, you don't put anything in front, you know, not mono, not di, nothing like that. You name the metal. You then write the name of the nonmetal, fluorine. And you change the ending of the nonmetal to IDE. IDE means it's in a compound. It means that it is not a magnesium and a fluorine atom. It is the compound magnesium fluoride. All binary compounds end in IDE. Every single one of them. But not every compound that ends in IDE is binary. Okay? So every single one of these compounds end in IDE that we are going to start naming. You don't worry about the subscripts when you write the names. I don't care what the subscripts were. You write the name of the metal, you write the name of the nonmetal, you change the ending to IDE. By the way, these are the ones. Nonmetals, there aren't many of them. There are not many of them. So, fluorine becomes fluoride. Chlorine, chloride. Bromine, bromide. Iodine, iodide. Astatine, astatide. Oxygen becomes oxide. They go all the way back to the X because oxygen didn't sound very good. So they go all the way back to oxide. Sulfur, sulfide. Selenium, seleniide. Tellurium, telluride. Don't worry, selenium and tellurium, you're not going to use them in any compounds. Nitrogen, nitride. Phosphorus, they go all the way back to the H, phosphide. Arsenic, arsenide. Carbon, carbide. Silicon, silicide. Boron would technically boride. Probably not going to ever get it in a compound. And what would hydrogen become? Hydride. That's all of them. That's all of the possible nonmetals that there are, ladies and gentlemen. Every single one of them. Questions? Now, here's what I will tell you. On a test, I will accept minor spelling errors. Minor. A minor spelling error is not accidentally forgetting to change INE to IDE and leaving it INE.
Like if I put oxygen, would that be fine?
I would give you credit for that, yes. If you put phosphoride and left the OR in there, I would give you credit for that. Hopefully over time you will learn them. But again, we'll get there. All right. So if we got the compound Na +1 and Cl -1. First of all, one important thing. Total charge on the compound must always be 0. So we are going to do the crisscross method here. The +1 goes down by the Cl, the -1 comes down by the Na. So Na -1 Cl +1 becomes NaCl. We get rid of the signs and we never write what number? 1. So this becomes NaCl. The little numbers at the bottom are done by Control and comma key on your keyboard. Control and comma will put you into a subscript mode. Control and period will put you into a subscript mode or a superscript mode. So that's the way I do the ones at the top is control and period. The ones at the bottom is control and comma.
How do you do the arrow?
That I have to insert a special character.
Well, just do 2 of these and then this.
Yeah, 2 dots and then the greater then I think automatically does it for you, right?
Yeah.
Good call, Brinley. Good call.
Whoa.
I'm genius. It's whatever.
Whatever.
It's a curse and a blessing. Blessing and curse. Curse. Blessing.
It's both.
It's something.
Okay. Alright.
Okay.
Oh shit.
Bang.
That's not funny.
It's okay because nobody left. All right. So now we've got magnesium, which is a +2, and nitrogen, which is a -3. Again, if you're wondering where these charges are coming from, that +2. Here's magnesium, it's a +2. Here's nitrogen, it's a -3. Everything can be found on the periodic table, ladies and gentlemen. So now, remember, the total charge on a compound must be 0. So I've got to combine these so the total charge is 0. Here's where the crisscross method is really handy, ladies and gentlemen. Because again, trying to figure out what you need to do, how many +2s equal how many -3s, just do the crisscross method. Take the -3 from by the nitrogen, put it down by the magnesium. Take the +2 from by the magnesium, put it down by the nitrogen. All we then do is drop the charges, ladies and gentlemen, the plus and the minus. Can 3 and 2 be reduced?
No.
No, then you're done. That's it. That's the only other thing you have to check for.
Wait.
Can they be reduced?
How could you reduce them?
Well-
Just like if they were both multiples of 2.
Both multiples of 2, 2 and 4, 3 and 3. So there aren't a lot of combinations that get reduced, but there are some. You are correct. A 2 and a 2. A 2 and a 4. 4 and a 2. It's possible to have a 2 and a 6 with some of the transition
And
metals.
that would just be like a 1 and a 3.
Correct. You're going to reduce it down.
A 3. Yes, you don't put ones.
Correct. But he's right. The
Okay.
ratio reduces to a 1 and a 3. We don't write 1s, so we would put a 3 by something. Yes. Questions?
I understand. Chemistry. What? So wrong.
Anyone need more time? All right. What if we put potassium +1 with oxygen, a -2? Total charge must be 0. So we end up crisscrossing. The +2 comes down, or I'm sorry, the -2 comes down by the K. The +1 ends up by the oxygen. We never write 1s, we never write positive, and we get rid of the negative sign in front of the 2. K2O. This is the reason for the compounds that we have, ladies and gentlemen.
Okay, oh.
Heck, why is it so small?
Wait, but I thought we were gonna write the ones.
We did. I put it down here so you could see where it came to,
Okay.
and then I got rid of it in my final formula.
Okay.
Okay? So I did the crisscross method. I put these down here. Now again, as you get better with this, I would never write a +1 down here because I know I'm just going to get rid of it anyway. The same way when I put the number here, I would just put a 2 here. I wouldn't put the minus sign in front. But I'm just doing this so you can see this number up here came down to by here. This number here ended up down here. Okay? And then cleaning it up, this is the way you would have to write it. All right? Okay, somebody pick a metal for me. Any metal.
Vanadium.
What?
Vanadium.
Vanadium. Okay, what's its charge? Okay, then don't pick one that you can't tell me the charge.
Beryllium.
Beryllium, what's its charge?
+2.
I know. I did, and you picked one, and so then I had to tell you, find me one that you could only do a charge on. Let's put this with carbon. What's the charge of carbon?
14.
14.
Yep.
So much for that understanding this, huh, Brinley?
JK.
I know. So here we do the crisscross method. Our compound becomes BE negative 4 C plus 2. Now again, I can get rid of the positive and negative. When you look at these though, this is a case where 4 and 2 can what? 4 and 2 can be reduced. And we have to reduce this, ladies and gentlemen. So this becomes BE2C. That would be our compound. Here's a case of where you have to reduce. Okay? Questions? By the way, when you write a compound, ladies and gentlemen, like this, please don't do this. Do not leave those charges in above. Don't do that. The charges are gone when you do the crisscross method. Don't do that. Don't do this. Don't leave enough space in between that you could drive a small car in between them. Now it doesn't look like a compound. Now it looks like two different elements. Please don't do that. What's wrong there?
It looks like an uppercase.
What?
It looks like an uppercase.
That's because that is an uppercase E.
Oh well.
That would be wrong. Okay? If you use two capital letters in a symbol, even though one is smaller, you will be wrong. Okay? Questions? All right. So what would be the compound for PB plus 4 and S minus 2?
Whoa. PBS2?
Yeah.
So Public Broadcasting System 2?
Yeah.
With a lowercase b though.
When you bring them down, PB minus 2, S plus 4. These can be reduced by 2 to PB S2. Correct.
What about the 4?
What?
What about the 4?
It became the 2. We reduced this by 2. We reduced this by 2. This became 1. This became 2. This is the reduced form.
I thought you said there was no math for this.
Yeah. Wait a minute.
I think you lied.
Why are we shocked?
Questions?
Why is the math in this?
You know, I guess it's just one of those things you can't get away from, no matter how hard you try.
Yeah, how are we supposed to know if the number goes in between both of the names or after?
You just do.
Goes in between both of the names or after. I don't know what you mean by that.
She's just saying, how do you know if it goes in between the compounds or if it goes after?
Like if the PB.
Because like some of them you put like the 2 in between the P and the
Well, again,
that's what she said.
we had a 2 and a 4 here, right? We reduced them. When we reduce them, we put whatever number is reduced by it. So this becomes a 1. That's why we didn't put a number there. And this is a 2. Let's go and so, all right, let's do strontium. What's the charge on strontium?
+2.
Plus 2. Let's put it with bromine. What's the charge on bromine? -1. So we're going to do the crisscross method, and we're going to bring this down by the SR. We're going to bring this down by the BR. So what would it be? SR minus 1. Is there any sense in me writing minus or 1? No. BR 2. Right? Question. Okay. So now let's take cesium plus 1 and put it with oxygen minus 2. This goes here. This goes here. CS what? O. Done. So why you put it in between and why you put it after is totally dependent on charges. We want the charges to always equal 0. So we're doing the crisscross method to get it to 0. Sometimes the crisscross method is going to put a number outside. Sometimes it's going to put a number in between. Sometimes it'll put a number in both. We want the total charge to always be 0. Okay? So let's go with barium plus 2. Let's go with phosphorus minus 3. 3's coming down there. 2's coming down there. Now I'm going to end up with it in between both places. So now, ladies and gentlemen, I end up with BA what? 3, P 2. Sometimes you got to put one by each. It's all about getting the total charge to 0. And that is what the crisscross method does. It gets you a total charge of 0. Okay? Now, in this compound, how many SRs are in this compound? How many strontiums? 1. And what's the charge of it?
Would it be negative?
Nope.
Or no?
Plus 2.
Oh, yeah.
In this compound, how many bromines are there?
2. No. Yeah.
And what's the charge of each one?
-1.
Well, 1 plus 2 is a positive 2. 2 negative 1s is
Nope. Negative.
2 negative 1s. Don't multiply them. 2 negative 1s is how much?
Well, you did multiply.
No, well, I didn't multiply the negative 1s together. I multiplied 2 times negative 1. Or you could add 2 negative 1s. What are you going to get? Negative 2. Plus 2 and negative 2 equals 0. There's your total charge. Okay? Down here, there are 3 bariums. 3 of them. Right? That's the number of them. The charge is a plus 2. If we take 3 positive 2s and either add them or multiply positive 2 times 3, what do we get? We get plus 6, correct? Here, there are 2. That's the number of them. What's the charge on phosphorus? Negative 3s. So there are 2 negative 3s, which is a charge of? Total charge always works out to be 0. Total charge always works out to be 0. Okay? Questions? Now again, we could write this CS4O2. Still have a charge of 0. But we don't want 2 different ways of writing the same compound. So we reduce these into lowest terms always. That is the reason we reduce them. There would be multiple ways of writing the same exact compound, to still get a charge of 0. But we don't want multiples of this. We don't want CS4O2. We don't want CS6O3. Too many different ways of writing the same compound. So we always reduce to lowest terms. Questions? Okay. So what's the charge on aluminum? What? +3. What's the charge on bromine? -1. So what would be the compound of these two? You crisscross them, you put them together, what would be the compound?
AIBR3.
A what?
AL.
AL.
Okay.
BR3.
Yes, correct. I didn't know if you said AI or AL. AlBr3. This -1 goes by the AL. This +3 goes by the BR. We clean it up by getting rid of the minus sign and the 1. We get rid of the plus sign. That is what we are left with. Total charge of 0 on the compound. Questions? Any metal and any non-metal can be made into a compound this way. Questions? All right. So now we're going to name a compound. Now we've got a compound written here. Now we're going to name it. So what is Al? Aluminum. What is Cl? Chlorine. So what would the name of this compound be? Aluminum chloride. We write the name of the metal. We write the name of the non-metal. We change the ending to IDE. Boom. That's the entire naming system. Aluminum chloride. Don't have to worry about the 3. Don't have to worry about the 1 by aluminum. Name the metal, name the non-metal, change the ending to IDE. Jasmine, what's Zn on the periodic table? It's element number 30, by the way. What's O? So what would the compound be? Perfect. Zinc oxide. Zinc oxide. Zinc and oxygen become zinc oxide. Rocio, what's Ra?
Radium.
Radium. What's C?
Carbon.
So what's the compound?
Radium. Carbon.
You got it. Radium carbide. Radium, Ra, carbon becomes carbide with the IDE ending. That's the name for this. You don't worry about the subscripts when you are writing names. Name the metal, name the non-metal, change the ending to IDE. Questions? Ga2S3. Jin, what's Ga? Gallium. What's S? So what would the compound be? Gallium sulfide. Perfect. There you go. That's the naming. Brenda, I know you got here late. But what's Ca on your periodic table? What's P? P. Phosphorus. Okay? So, go. Now we need to change the ending to what? IDE. So phosphorus, go all the way back to the pH. Drop that OROS and put the IDE on it. Calcium phosphide. Perfect. Perfect. Okay? Avon, BAI2. You're fine. Barium what? What was that? Remember it has to end in IDE. Iodine. Thank you. Sometimes it's hard for me to hear if you're putting the IDE or if you're leaving it INE. Barium iodide. Questions, ladies and gentlemen? Okay. Here you go, ladies and gentlemen. Binary ionic compound worksheet. What is an ion? Give an example of a cation, give an example of an anion. Remember, cations are what? Positive. Anions are? If you write just magnesium here, that is wrong. Why? Needs to have a plus or a minus charge to become an ion. So write the symbol and put the plus or minus charge. You'll notice up at the top here, Control plus the comma key is how you make a subscript. Control plus the period key is how you will make a superscript. So if you need to do charges, after you type in the symbol, hit Control and period on your keyboard. Whatever you type afterwards will then go in a superscript mode above. Okay? Write the charges you are most likely to expect for each of these based off of where they are at on the periodic table. And then start naming these. Okay? Start naming these. And then here, ladies and gentlemen, you are going to write formulas for these. Now, do not worry about the ones that are iron 3 sulfide, chromium V nitride. I'll explain those tomorrow, ladies and gentlemen. You've got plenty to do to occupy the next few minutes, and if you have questions, please feel free to ask. Okay? By the way, if you were not here because you were gone to the Career Center or whatever, if you want to see what I did to the periodic table, if you want to add notes to it that I added, the charges and things, it'll be sitting up here, ladies and gentlemen. You can come up and you can borrow it, and you can take and make it into what you, or make it how yours looks like that for the charges. Silver's 47 on your periodic table.